Okay, so today's chapter is chemical equilibrium. It's a very fundamental unit, but mostly question of this is there in JEE advanced paper. So and you can say it is like initial phase of fine equilibrium also. तो थोड़ा सा फोकस करेंगे पोर्शंस को स्टडी करने में. So let's begin and we'll proceed with the questions only because I don't think so इसमें बहुत ज़्यादा क्वेश्चन लाइक थ्योरी रिक्वायर्ड है. जहाँ भी ज़रूरत पड़ेगी वहाँ क्वेश्चंस के साथ ही मैं आपको थ्योरी का पार्ट बता दूंगा क्योंकि बहुत बेसिक थ्योरी है और आप में से ज़्यादातर लोगों को चैप्टर क्लियर होगा. So we'll go with certain questions. तो सबसे पहला क्वेश्चन हमने लिया. इट्स गिवन that formation constant of NiNS3 whole twice whole 6 2 plus is 6 into 10 power 8. So all of you can notice the equilibrium constant is much larger value. At 25 degrees Celsius, if 50 ml of 2m ammonia is added to 50 ml of 0.2m solution of nickel 2 plus, the concentration of nickel 2 plus ion is nearly equal to. So first thing all of you must notice is that 50 ml of 0.2 ammonia is added to 50 ml of 0.2 of nickel solution. So both the concentrations becomes half. So concentration of nickel 2 plus become 0.1 and that of ammonia becomes 1m. Then since equilibrium constant is a much larger value, so this equilibrium will shift almost in the complete forward direction. So some of you may write as 0.1 minus x, then 1 minus 6x and then x. But as we know that this is a very higher equilibrium constant equation, so 0.1 minus x will tends to 0, or we can simply say x will be approximately 0.1. So since x is approximately 0.1, then another concentration of ammonia can be considered as y. You all know that in equilibrium we can't take any concentration as 0. So once you will take this concentration as y, so ammonia concentration will left over 0.4 and this is 0.1. And now if I'll apply the equilibrium constant which is Kf, it will be concentration of NiNS3 whole 6 2 plus upon concentration of nickel 2 plus into concentration of ammonia power 6. Just substitute the values, so it will become 0.1 upon 0.4 power 6 into y. And this is given to you 6 into 10 to the power 8. Just simplify y from here, it will come out to be 6 into 10 to the it will come out to be 0.1 into 10 to the power minus 8 upon 6 into 0.4 power 6. And 0.4 power 6 can be written as 4096 into 10 power minus 6, or you can simply write 4.096. So this becomes 10 to the power 9 upon 6 into 4.096 into 10 to the power minus 3, like this. Okay. So just simplify, it will come out to be y is approximately 1 by 24 into 10 power minus 6m, or more closest if you write, it will be 4 into 10 to the power minus 8m. Very simple calculation. Like for the calculation part, you definitely all of you must check. So this will be your answer. Now we'll take the another question of almost similar type to just make you more clear about this concept, because this is the only concept in chemical equilibrium where some of you may get trouble. Again, this asks how many moles of ammonia is added to 2 liters of 0.8 m AgNO3 in order to reduce the Ag plus concentration to 5 into 10 to the power minus 8 m. Again, Kf is given. So almost similar question. The difference is we have now added ammonia in the solid form, so concentration of AgNO3 should not be affected, which we have affected in the earlier question because we have used the volume of the two solutions. So here, like differences, we have added ammonia in the Ag plus solution, so it has converted into AgNS3 whole twice plus, and since it is a equilibrium with the equilibrium constant of 10 to the power 8. And in the question itself, it's given that the concentration of Ag plus left after the reaction is, so we have taken 2 liters 0.8 m, which is, if we'll calculate with respect to mole, so it is 0.8 into 2, which is 1.6 mole. If you balance the equation, it will become 2NH3. And since you know after the reaction that moles of uh, Ag plus leftover is 5 into 10 power minus 8, so all of you can understand it is approximately 0. means complete 1.6 moles of Ag plus has consumed. So once this 1.6 mole has consumed, that means initially whatever moles of ammonia we have taken X, now it is X minus 3.2 moles. And post reaction, it will form 1.6 moles. Clear? So now if I'll substitute in terms of concentration, be very careful here. You have to put concentration. So volume will use 2 liters directly. So it will become concentration of AgNH3 whole twice plus divided by concentration of Ag plus into ammonia square. Just substitute the value. So it is 1.6 by 2 divided by Ag plus concentration is given directly 5 into 10 power minus 8. And ammonia concentration will be X minus 3.2 by 2 square. And Kf is given to you 10 to the power 8. So 10 power 8 is equal to, this is 0.8 upon 5 into 10 power minus 8. And if you will simplify this value, so into 4 into x minus 3.2 square. From here, you have to calculate x. So x minus 3.2 square will be equal to approximately how much it is? 10 power minus 8 will be cancelled. So 3.2 by 5. You can also write as 64 by 100. Let's take a root. So it is x minus 3.2 is equal to 0.8. X will be equal to 4. This is your answer. And be very careful in J advanced paper. Calculations are there in J like equilibrium kind of questions. So be very careful about while you are doing calculations. Such type of mistake should not happen that you are doing it right and you are making mistake. Especially equilibrium is a very easy chapter, or better to say chemical equilibrium is a very easy chapter. Don't confuse with ionic equilibrium. It is one of the easiest unit possible. So be very careful in this unit that calculation part mostly mistake happens in terms of moles, concentration. So whenever you are doing calculations, be careful. Everywhere we have to put concentration. Whenever it is asked moles, calculate in terms of first calculate concentration and then convert it to moles. Or if you are using moles, then be careful about the volume. Like in this question, if you miss the 2 liter volume, your calculation leads to a wrong answer. So be very precise about all these calculations. Chemical equilibrium is very important with respect to calculation part. Next question we can tackle this one. I'm taking most of the case of heterogeneous equilibrium. Some homogeneous equilibrium also will take at the later stage. Initially, I'm taking such questions so that your fear get reduced because these are the portions of chemical equilibrium where mostly students are like affected with respect to calculation part. So it's given next question for equilibrium at 300 Kelvin, LiCl dot 3 NH3 solid and LiCl NH3 solid and 2 ammonia Kp is given 9 atmosphere. So like I hope all of you can understand that here partial pressure of ammonia can be calculated at equilibrium. Partial pressure of ammonia can be calculated at equilibrium because the other two substances are solid. So here I can write partial pressure of ammonia square will be equal to Kp. So at equilibrium, partial pressure of ammonia will be how much? T, because Kp is given 9. Now it's given that 8.2 liter vessel, 1.4 LiCl dot NH3 and 2.8 mole of ammonia were placed. Moles of LiCl dot 3 NH3 formed in the equilibrium. So since partial pressure of ammonia is given 3, so with respect to this, we can calculate first of all moles of ammonia. So simply you have to apply PV is equal to nRT. Pressure is given 3, volume is given 8.21 liters. Number of moles you have to find out. R is 0.0821. Temperature is given to you 300 Kelvin. You just simplify, you'll get N is equal to 1. So in this reaction, LiCl dot 3 NH3, once equilibrium has achieved, at that time, moles of ammonia is 1. So in the starting, it's given 2.8 moles. starting it's given 2.8 moles of ammonia and 1.4 moles of LiCl.NH3. At equilibrium it is 1 mole. So how much it is consumed? 1.8 mole. And if it is 1.8 mole is consumed, so 1.4 minus 0.9 moles has consumed here. So leftover is 0.5 mole and same 0.9 moles will form here. And the question is asked that how many moles of LiCl.3 NH3 is formed. So we can write answer as 0.9. So answer for this question will be 0.9 moles. Okay, clear? Now, many of you have written like simultaneous equilibrium we have to discuss. So I'm starting with a smaller question first, and then we go some more tricky questions towards the end for like simultaneous equilibrium. First, to make your concept clear, and along with the concept where like how you have to take the neglection when concentration of some equilibrium constant is much higher or much lower. So I've taken both the concepts together in a in a single question, just to make both the concept clear. So let's say it's given amount of 1 mole of each A and D is introduced in 1 liter container. Simultaneously, the following two equilibriums were established. You can notice that equilibrium constant for first equilibrium is 10 to the power 6 m, whereas for the another equilibrium it is 10 to the power minus 6 m. Means one equilibrium has very higher value and the other one has very lower value. So if I put both the equilibrium together, so first it will become A gives B plus C, and its equilibrium constant is 10 to the power 6. Second equation is given B plus D gives A. And you can notice in the first equation A is reactant and the second equation A is product. And Kc is given to you 10 to the power minus 6. Since we have 1 mole of A and 1 mole of D, so once equilibrium is established, you can see that for first equation, equilibrium constant is much larger value 10 power 6. So this equilibrium will shift almost complete forward. So I can write it as value Y. This will be 1, this will be 1. And most certainly I can write that y will be tending to 0, but it is not 0. Be very careful and precise that in any equilibrium question, you should not take you should not take concentration of any reactant or product as 0. So I hope it is clear. So now Kc is 10 to the power 6, so it's very larger value. So y will be most certainly tending to 0, but you can't take it 0. Whereas for the second step, once B has formed 1 mole, so like that same value can be used for the next equilibrium, which is 1. D is already 1. And now equilibrium constant is a very smaller value. So this equilibrium shifts in the forward direction very less. It will shift in the forward direction very less. So that is also almost tending to 0 value. So you can write it again as Y. Or you may write Z. Y plus Z is also negligible. That way also you can write. If you want to increase the variables, it's up to you. So you can write it will be approximately Z, and Z is also tending to 0. But since it is an equilibrium, so since in the first step it is left over is Y, and in the last step it is Z, so we can write here plus Y, and here we can write Z. Since both the values are negligible, so certainly you can write it as tending to 0. So make it a separate variable, let's say A. It's your choice. If you want to introduce two variables, it's your choice, or else we can simply write Y also. So for first equilibrium, it will be active mass of B into C by A is equal to 10 to the power 6. While for the second equilibrium, it is active mass of A into B by D is equal to 10 power minus 6. So if I'll consider the concentration of A as Y, so Y will come out to be 10 to the power minus 6 from first expression also. And the similar value is satisfied in the second expression also. So a very easy question, but the framing of question is little tricky. So be careful about such type of questions where equilibrium constant is much larger and much smaller in the same question. So approximations are very important, and since it is a case of simultaneous equilibrium also, so concentration should also be handled very wisely. So answer is 10 to the power minus 6 for the concentration of A. Clear? Now to the next question. On the next question, it's given that amount of 1 of mole of PCl3 gaseous and 1 mole of PCl5 gaseous is taken in a vessel of 10 liter capacity. maintained at 400 Kelvin. The equilibrium moles of Cl2 are given, and you have to discuss about a few things. So it's given Kc for the reaction is PCl5 gaseous is BCl3 gaseous plus Cl2 gaseous. So first thing, like all of you must notice that in this equilibrium constant is not given, but the concentration of Cl2 you can notice it's given a very smaller value. So we have 1 mole of PCl3 and PCl5 in the starting, and the vessel capacity is 10 liter. So moles will be certain, concentration is zero point 0.1 each in the beginning, it's given 0 in the starting. And once equilibrium has established, at that time the concentration of Cl2 will be, because moles formed is given 0.004, so concentration will be 0.0004. And you can notice if this amount will like consume in the PCl5 thing and we'll add in the PCl3, that will be certainly a negligible value. Like if I write first in terms of variables, I can write it as zero point 0.1 minus x, zero point 0.1 plus x, and x. And since x is given to you 0.0004, 0004 basically. So certainly it is a negligible value. So you can say that equilibrium constant for this expression will be a quite lower value. And once I'll calculate Kc, then it will be active mass of Cl2 into active mass of PCl3 upon active mass of PCl5. And since the concentration of Cl2 is negligible, so 1.1 plus x and zero point 0.1 minus x will be a very close value. So need not to do any calculation. So this will be approximately equal to the concentration of Cl2, which we can write as 0.0004 m. That means your option A is correct. I wish all of you have understood. Next part is given Kp is PCl3 plus Cl2 is PCl5. So this is also another concept. Every one of you are aware of that. Kp is equal to Kc into RT par delta N. But in this case, like all of you can notice that it's given reverse reaction. So if reaction is reverse, equilibrium constant will be 1 upon K. So expression wise, it's written correct. Kp is equal to Kc into RT par delta N. And the temperature is given 400 Kelvin. So for given reaction, Kp is correct. So, but since in the question reaction is reversed, you can all of you can notice this thing that here reaction is reversed. So its equilibrium constant will be 1 upon K this value. So option B is not correct. So the equation given to you now PCl3 plus Cl2 gives PCl5. So its Kp will be equal to 1 upon 0.0004 into RT, which is 0.0821 into temperature. Third part is given if PCl3 gaseous is added to the equilibrium mixture, the delta G at the new equilibrium becomes greater than the delta G old value. Now see, in equilibrium question, this is the basic challenge. One or two options are given, very routine options. Then some tricky options are given, which you have to check every time. So my suggestion is like whenever such type of questions are there, just check it very carefully. So now it's given PCl3 is added to the equilibrium mixture. So it means you have affected the Q value. And we all know that if I have to calculate delta G expression, so it is delta G equal to delta G naught plus RT ln of Q. Delta G naught is basically dependent on equilibrium, which is minus RT ln of K equilibrium, which is a fixed value because equilibrium constant is known without changing the temperature. And since you are increasing the concentration of PCl3, that means the concentrate Q value will be active mass of PCl3 into Cl2 upon PCl5. Okay. And be careful, the question is asked about delta G, not about delta G naught. So once you have added PCl3 concentration, that means you have increased Q. Once you have increased Q, then ln Q value will increase. So delta G will be certainly enhanced. So it's given delta G at new equilibrium becomes greater than the delta G at old equilibrium. So this is not correct now. This is not correct because it is delta G naught plus RT ln of K equilibrium. And you all can notice that the value of Q will be certainly less than 1. So it will be a negative value. So certainly this value will be decreased. So if PCl3 gaseous is added to the equilibrium mixture, delta G at new equilibrium becomes greater than the delta G at the old equilibrium. This is not correct. Clear? Now the last option at equilibrium is achieved. Moles of PCl are doubled and moles of Cl2 are half. Okay, so after equilibrium is achieved, moles of PCl3 and PCl3 is added. So if PCl3 is doubled and Cl2 is half, so that will be no effect in the equilibrium. So equilibrium is already maintained. So this is also a correct option. So your answer will be A and D. Clear? Because once you write Q, which I have written, if I'll double the PCl3 concentration and I'll half the concentration of Cl2, Q remains same. So equilibrium not affected. So equilibrium is not affected. So our answer will be A and D. Clear? Now we can go to the next question, which is this one. So this is basically a paragraph, like matching type of question. So this is to explain a lot of concepts in a single question. So just watch it carefully. Now it's given that we have AB3 is reacting if A2 and 2B2 and four more equilibriums are given, which you have to like match with the different side, right side different columns. So first given is introduction of B2 at constant volume shifts the equilibrium in the backward direction. So all of you can notice that for all the equilibrium, B2 is the product of the reaction. So you must know that if the concentration of product will increase, equilibrium shifts in backward direction. That means option P is for all, correct? Second one is given alpha increases on increasing temperature. So you can see all the equations are more or less thermal decomposition because we are heating some substance and we are breaking it to the other parts. So all the reactions are endothermic reactions. Since all are endothermic reactions, so temperature increase means equilibrium constant increase. And once equilibrium constant is increased, that means alpha is suddenly increasing. So since all the reactions are delta H not positive, that means endothermic reactions. How I have predicted that thing? Because all are decomposition reactions. So all are endothermic reactions. So if you increase temperature, their equilibrium constant will increase. And since equilibrium constant has increased, then certainly alpha will also increase. So alpha increases on increasing temperature. That's true. So that is also a correct option for all. Now it's given on adding inert gas at constant pressure, equilibrium concentration will change. This is very important. If we add inert gas at constant pressure, so in this situation, delta and positive reaction shifts forward direction. Delta and zero means equilibrium unaffected. So no effect on equilibrium position. And if delta n is negative, it is backward shift. And just watch this question very carefully because most of you commit mistake at such place. We are discussing about the effect on equilibrium. So if it is delta n positive, equilibrium will shift in the forward direction. If delta n is zero, no effect on equilibrium. And if delta n is negative, it is backward shift. But notice here in this question, they haven't asked about the equilibrium. They have asked about the equilibrium concentration. So if even if equilibrium is not affected, that means moles of reactant will not change. Or better to say that concentration at that particular equilibrium is not changed. But since you have changed the pressure, since it is a constant pressure thing, that means volume of the container has affected. And once volume of the container has affected, that means concentration of all the reactants will change. New concentrations will be achieved. So on addition of inert gas at constant pressure, equilibrium concentrations will change. That is correct. And it is correct for A, B, and C. It's not correct for D because it is a case where one substance is solid So in this case, once I'll write Kp, this will be equal to partial pressure of A gaseous into partial pressure of B2. And of inert gas, on addition of inert gas, partial pressure of any substance will not change because it will not react with any of the reactant or product. Since you have added inert gas at constant pressure thing, so partial pressure of all the substances whichever is present in that particular reaction vessel, total pressure will change because you have added an inert gas. Its initial extra pressure will be enhanced. Total pressure will change, but the pressure of this particular substance or this particular gases are fixed value. So once you have added inert gas at constant pressure, so in this reaction, the concentration of equilibrium concentration of all the substances will be unaffected. Okay. And the next part is given on increasing the pressure, concentration of all reactants increases. So if you increase the pressure means you are going to decrease the volume. And once you decrease the volume, that means concentration of all the substances will affect it. So this is also an option which is valid for all except the D option. Because in D option, when you are heating a solid, you are getting gaseous substances. So as the equilibrium is affected, that solid will consume and again equilibrium will be reestablished. So concentration of A and B2 will remain constant value. They cannot be affected because AB2 term is not involved in terms of volume. And the last one is given alpha is independent of equilibrium pressure. So this is only valid for delta and zero. Because if alpha is unaffected by pressure, alpha unaffected by pressure, then it is a case of delta and zero, which is option C. So if I match the options, so A will match with P, Q, R and S. B will match with P, Q, R and S again. C will match with P, Q, R, S and T. And D will be matching with P and Q. Very important, notice it carefully. On addition of inert gas at constant pressure, delta and zero case equilibrium is not affected. Delta and positive equilibrium is affected. Delta and negative equilibrium is affected. So equilibrium is affected means concentration of different substances will be altered. C option, it is a case of delta and zero. You have added inert gas, equilibrium is not affected. That means total moles of AB, A2, B2 will remain same. They are not disturbed at any point. But since you have added an inert gas at constant pressure, that means you have changed the volume of the total container. So that volume has affected the total concentration of all the substances. But since that volume term will be cancelled out, that's why this equilibrium has not affected. I think I have to explain a little more because it is little tricky part. So if let's say for option C, I'll write it as 2AB is A2 plus B2, I think. Yes, so this is the expression. So once I'll write its QC part, it will be active mass of A2 into B2 upon AB square. And here if I'll write the moles thing, so I can write moles of A2 by volume, moles of B2 by volume, divided by moles of AB by volume square. So since you have added inert gas at constant pressure, so if pressure is constant, moles has increased, so certainly volume has increased. And since volume will be cancelled out in this expression, so QC will be remain equal to KC. So equilibrium is not affected. That's true. Equilibrium is not affected. But if I'll ask about the concentration of A2, so it will be moles of A2 by new volume V1. And since V1 is not equal to initial, or you can write final volume, I can write. So final volume is not equal to initial volume. So definitely concentration has changed. Just notice it very carefully. There are two different things which we are discussing. Equilibrium is not affected because volume term is cancelled out in case of delta and zero. So Q remains K, equilibrium is maintained. But since the volume has changed, then concentration of all the substances will change. I think it's very clear and it's very important also because this is the biggest point. Really, this is the, like you can say, very common mistake which most of the student commits because they feel that equilibrium is unaffected, correct? Because volume has term cancelled out, so Q remains K. No effect on equilibrium, but changes concentration is there. Is that clear? While in the option of D, it is an heterogeneous equilibrium. So here, once equilibrium is maintained, again, okay. So in this case, the equilibrium has affected. So gaseous concentrations are dependent on the solid concentration. So again, equilibrium will be attained and will reach to the same concentration level what were present earlier. Because by that time, it is not equal there because denominator term is not there. Like option D also requires a little more explanation. So in option D, since one substance is solid, so it's given AB2 solid and it will form A gaseous and B2 gaseous, A gaseous and B2 gaseous. So here if I'll write, let's say Q, so it is actually concentration of A into B2. So whatsoever you do, initial concentration of A and initial concentration of B must be equal to final concentration of A and final concentration of B. Then only equilibrium will be like restored. So if initially K is equal to K equilibrium, you have added inert gas. So if you have added inert gas, pressure is constant, but volume has increased. And since volume has increased, equilibrium is disturbed, then it will regain the equilibrium. This equilibrium will shift in such a manner that again equilibrium is restored. So since volume has increased, concentration of A and B2 will decrease initially. So more AB2 will shift in the forward direction. Again, concentration reach to the same value. So since volume has increased, moles of A and B2 will also increase to get the equilibrium again. So finally, once equilibrium is attained, concentration of A and B2 are unaffected. Because in the denominator, concentration of AB2 is not there, so volume term cannot be regulated only by the change of volume. That should be regulated with the change of moles. And change of moles and change of volume will be in such a manner that equilibrium is restored again. So concentration of A and B2 will be same once equilibrium is restored. Very good question. Just understand it very clearly. So it's options C and D are very important. Other options like most of you can tackle easily, but options C and D, and that too comparison of R and S option is very important. So R and S will not match with D since although delta n is non-zero, and R and S both will match with C although delta n is zero. So delta n zero will not affect the equilibrium, that's true. But for concentration, we need two terms, moles and volume. Since volume has changed, mole will change. And in case of option D, since volume has changed, moles must also change because in the denominator, there is no term to regulate that volume term. In delta n zero, since volume gets cancelled out, moles will not be affected. I think I'm very much clear. It's very important question for those who are like not very much pro about chemical equilibrium. Now I'm taking one more question to make your concept more clear with respect to Lee-Chatelier's principle. If some of you are not very much clear about that, so just understand that's why I've given little more explanation. If it is clear, we can move to the next question. It's given among the following the total number of equilibrium. So total number of equilibrium in which the forward reaction would be favored on increase of pressure at constant temperature. This is the question. So like you have to just read the effect of pressure in all the cases. So just start with first option. So you can see that first case is delta n zero. So let me write this first case is delta n zero. And since it is delta n zero, so it has no effect of pressure. Equilibrium will not be disturbed. And here notice that question is different. Here question is that whether equilibrium is affected or not. So if delta n zero and you are increasing the pressure, no effect on equilibrium. Next question also it is delta n zero again. Check it carefully. In delta and 0, we are taking only gaseous reactant and gaseous product. Solid is not involved. So delta n is 0 again. So it is again no effect. Next case, it is carbon solid and half of oxygen gaseous if 2 CO gaseous. So in this case, what happened? Delta n is positive. Since delta n is positive and you're increasing pressure, so it will shift in the backward direction. Next case, it is delta n negative. So this is forward shift. These are routine cases because in numerical type of question, only one or two options are tricky. Most of the options are routine where we can directly solve the question. But if one option has stuck, means you don't know the complete question because without clearing that one option, you can't answer the question. So this is forward shift, and in the question it is asked forward shift. So this is our answer. Next, it is given H2O2 reacts with water, heat on heating is water and half of oxygen gases. So this is also a case of delta and positive again. So this is also backward shift. Next case is delta and negative. So this is forward shift. Next, it is given an equilibrium in which Kp is given to 2.5 into 10 to uh, 100 power minus 2 zero. It should be correction, I hope. It should be 10 to the power minus 2 atmosphere inverse. Just make it correct. It should be 10 to the power minus 2 atmosphere inverse. So in this question, like all of you can understand, since Kp is given, we are dealing option 7 now. So since Kp is given 2.5 into 10 to the power minus 2 atmosphere inverse. So with the unit of Kp, you can predict that it is delta n less than 0 because we know that unit of Kp is atmosphere power delta n. So it's given -1, so delta n is less than 0, or you can simply write delta n also. Delta n is -1. So you can say delta n negative. Delta n negative means this is also a case of this is also a case of forward reaction. And negative, so this is also a case of forward reaction. How I have predicted delta n negative with the unit. In the next part, it's given an equilibrium in which addition of inert gas at constant pressure favors the backward reaction. This is also a case of delta n negative. Because in the previous question, I have told you that if in case of inert gas at constant pressure, equilibrium is affected and it's shifting in the backward direction, so it's a case of delta n negative. So if it is a delta n negative, so on increase of pressure, it will shift in the forward direction, right? And the last part is given CH3, CHO liquid gives CH4 gaseous and CO gaseous. So this is also a case of delta n positive. But in this case, one more important thing is given. If the vapor pressure of CH3CHO is given to you at 300 Kelvin, 0.2 atmosphere, that means this value will remain constant by that time temperature is constant. So once you deal this equilibrium, that active mass of CH3CHO, we have to put the fixed value 0.2 atm. Still it is delta n positive. So this will shift in the backward direction. Clear? So here forward shift are total 4. You can mark this is 1, 2, 3, and 4. So your answer must be 4. Because the question it is asked in how many of the following cases total number of equilibrium in which forward reaction would be favored by increase of pressure. So there are 4 cases where such thing will happen. Option number 7 is important. Option number 8 is little tricky. Ninth one is also tricky because some vapor pressure concept has introduced. So that must be known to you very clearly. Then only you will be able to answer such type of question. Now it's given another question. This is also a very beautiful problem. Just check it carefully. So in the question, it's given that in 10-liter flask of at 400 Kelvin, equilibrium mixture contains PCl5, PCl3, and Cl2 at a pressure of 2 atmosphere, 1 atmosphere, and 1 atmosphere respectively. The volume of the flask was decreased to V liters, by which the pressure of PCl5 becomes 5.8 atmosphere. The value of 10 minus V is asked. Okay. So in this question also, basically it is the question in which you have to predict the direction of equilibrium. It's better to say QC KC concept you have to discuss. So let me write the equation first. PCl5 gives you PCl3 and Cl2. This is the expression. volume of the flask is in 10 liter, and the with two atmosphere, 1 atmosphere, and 1 atmosphere pressures are given. So these are the pressure given. So and this is given at equilibrium. So I can write Kp is equal to partial pressure of PCl3 into partial pressure of Cl2 upon partial pressure of PCl5. So with this, I can easily write that Kp will be equal to zero point 0.5. 1 into 1 by 2 is 0.5. This is given to you. Now it's given the volume of the flask was decreased to V liters. So if I decrease the volume, that means pressure of all the substances will be affected. So new pressure will be, so since temperature is constant, so PV is constant for all the substances. So if you have decreased the volume of the flask by V, so the new pressure will be 20 upon V. New pressure will be 2 atmosphere into 10 liter divided by V liters. This will be the new pressure. And this will be 10 by V and this will be 10 by V. So if I write Q, it will be 10 upon V into 10 upon V upon 20 upon V, which we can write as 10 upon 2V basically. And since it is given that volume has decreased to V liters, so V is certainly less than 10 liters. If V is less than 10 liters, then Q will be certainly greater than 0.5. If V is less than 10 liters, then this 10 upon V will be certainly greater than one value into half. So Q will be certainly greater than half, or better to say certainly greater than Kp. So equilibrium will shift now in backward direction. Equilibrium will shift in backward direction. Is that okay first? This is the only trick of the question which you have to predict. So once it will shift in the backward direction, then you have to reduce the pressure again. And it's given that once the equilibrium is attained, again PCl5 pressure becomes 5.8 atmosphere. So once a new equilibrium is established, PCl5 is PCl3 and Cl2. Then it is 10 by V, 10 by V and 20 by V. These are the initial pressures. And equilibrium will shifted from the backward direction. So 10 by V minus X, 10 by V minus X, and 20 by V plus X. And this 20 by V plus X value is given to you 5.8 atmosphere. Is that okay? And since the equilibrium has restored again, so then it will be 10 by V minus X into 10 by V minus X upon partial pressure of PCl5 is 5.8. This is equal to 1 by 2. So 10 by V minus X whole square must be equal to half of 5.8 is 2.9. Take approximately root of 2.9, it will be approximately 1.7 because 1.7 square is 2.89. Can I write it as 10 by V minus X is equal to 1.7? And another expression we have 20 by V plus X is equal to 5.8. If I'll add the two expressions, it will become 30 by V is equal to 5.8 plus 1.7, which is 7.5. So from this, I can write V is equal to 4 liters. Clear? So little calculative questions, but some important concepts are also there, which you should notice. One thing, by change of volume, partial pressures of all the substances are affected. Then you have to check Q. With Q, you have to decide whether it will shift in forward direction or backward direction. And once it is decided in the backward direction, you have to apply the question. One more concept we have used, that is PV equal to constant, which is stoichiometric thing. I have used over here. So to calculate the new pressure after degrees of volume V, it is P1 V1 equal to P2 V2 because temperature is constant. So answer is asked 10 minus V. Just see the question, the value of 10 minus V. So our answer will be 6. Be careful, answer is not 4. So our answer will be, so for the question is 10 minus V is 6 liters. This is our answer. Clear? Then to the next question. This is a question of simultaneous equilibrium. Little more calculation because here you will understand actual field of simultaneous equilibrium, because in ionic equilibrium lots of tricky questions are there where we have to tackle completely simultaneous equilibrium. In previous question of simultaneous equilibrium, like since approximations has worked out, so that much things we need not to calculate. So let's begin. So now it's given N2 plus 3H2 gives 2NH3. This is one equilibrium. So it's given in a vessel, two equilibrium are simultaneously established at same temperature as shown below. Initially, the vessel contains nitrogen and hydrogen in a molar ratio of 9:3. The equilibrium pressure is 7 P naught, in which the pressure due to ammonia is P naught and due to hydrogen is 2 P naught. Find the value of equilibrium constant Kp for both the reactions. So first equation is N2 plus 3H2 gives 2NH3. So let's say I write Kp1 for this expression. Next is N2 plus 2H2 gives 2 N2H4 gaseous. For this, let's say I'll write equilibrium constant as Kp2. Okay. Since it is given nitrogen, hydrogen and the molar ratio of 9:3, so molar ratio is same as the ratio of pressures. So can I write pressure of nitrogen as 9P1 and that of hydrogen is 13P1? And since it is a common vessel, so for both the equilibrium, this value will be same, 9P1 and 13P1, because mole ratio is given 9:13. And now if equilibrium will be established, so this 9P1 minus P will be there, 13P1 minus 3P will be there, it will form 2P. Okay. And or we can write P1, let's say, it would be good. Or better understanding, I'll make it P, let's say. So 9P and 13P are initially. And first after reaction, it's 9P minus P1, 13P minus 3P1 and 2P1. For next expression, it is minus P2 minus 2P2 and it will form P2. Okay. Now, since both are simultaneous equilibrium, so whatever pressure has decreased in the first step must be decreased in the second step also. And whatever has decreased in the first step must be decreased in the second step also. So here we have to do minus P2. Here we have to do minus 2P2. And in that bottom expression, we have to do minus P1. And here I have to do minus 3P1. Because partial pressure of nitrogen and hydrogen will be a constant value in both the expressions. Is that clear? Now, whatever data is given that we have to use. So first it is given that the equilibrium pressure is 7P naught. So we have to write the total pressure. So it's 9P minus P1. This is pressure of 9P1 minus 9P minus P1 minus P2. This is partial pressure of nitrogen plus, I'm writing in the bracket so that it should be clear. Then pressure of hydrogen is 13P minus 3P1 minus 2P2. Then partial pressure of ammonia is 2P1. Partial pressure of N2H4 is P2. This is given to you 7P naught. Second thing is given to you, partial pressure of ammonia is P naught. So I can write 2P1 as P naught, or simply P1 is now P naught by 2, which we can replace in all the parts. Third thing, it is given that the partial pressure of hydrogen is 2P naught. So I can write 13P minus 3P1 minus 2P2 as 2P naught. Okay. So if I'll put in the above expression, it will become 9P minus P1 minus P2, which is pressure of hydrogen, plus pressure of ammonia is given 2P1. So P1 is P naught by 2, so that I can write hydrogen as 2P naught, ammonia as P naught, plus P2 is equal to 7P naught. So you can see P2 will be easily cancelled. And now left over is 9P minus P1 is P naught by 2 plus 3P naught, or this is equal to 4P naught directly I can write. So from here, capital P can also be calculated. This basically P naught by 2 again. 9P will come out to be 9P naught by 2. Okay. So this is P naught by 2 now. Now substitute these two values in the expression of, let's say, hydrogen. So you'll get P2 value. So 13P naught by 2 minus 3P naught by 2 minus 2P2 is equal to 2P naught. From here, you have to calculate P2, which you will get as 3P naught by 2, I think. This is 5. It will come out to be 3P naught by 2. And now all the values are calculated. So we need partial pressure of different substances. So I can write partial pressure of ammonia as 9P naught by 2, or first I'll write in the original expression. So it's 9P minus P1 minus P2, which we can write as 9P naught by 2 minus P naught by 2 minus 3P naught by 2. So it will left out to be 5P naught by 2. Partial pressure of hydrogen we have already given in the question 2P naught. Partial pressure of ammonia is given to you P naught. And partial pressure of N2H4 will come out to be P2, which is 3P naught by 2. These are the expressions. So now calculate Kp values for both the expressions. I think it will be most easy part. Most of you will be able to solve. Which I can leave here also. So Kp1 for the first expression will be partial pressure of ammonia square upon partial pressure of N2 into partial pressure of H2 square. So this is P naught square upon 5P naught by 2 into 2P naught cube. This will be the expression. Just simplify it. It will come out to be, I think, 1 upon 20 P naught. 1 upon 20 P naught square. This is the answer. And similarly, if you will calculate Kp2, it will be partial pressure of N2H4 upon partial pressure of N2 into partial pressure of H2 square. Okay. Coefficients are 1 and 2. Again, substitute the values. It will be 3P naught by 2 divided by 5P naught by 2 into 2P naught square. This comes out to be 3 by 20P naught square. These are the final answers. Now, to simplify the question or to make the question in the form of like objective form, they may ask the ratio of the two. The ratio of the two will calculate. So you can simply see that it will get simple integral value 3. If you will relate here, Kp2 will be equal to 3 times of Kp1. Type or integer type for like JEE examination. So such type of things can be correlated in the form of ratio or maybe in the form of relation. But you should know the complete solving part. So in simultaneous equilibrium, what are the two important things? Like whatever amount or pressure has decreased for one substance in one equilibrium, it has to be taken care in the second equilibrium also. Because both the reactions are taking place in a same vessel. So partial pressure or concentration or any physical quantity which we are dealing for a particular substance would be constant for both the substances or both the equilibriums. Clear? Now to the another question. Here we are again tackling a heterogeneous equilibrium in which, like, again, vapor pressure concept has introduced. So this is also very important concept where humidity or vapor pressure kind of questions can be asked. So in this question is given copper sulfate dot 5H2O gives you copper sulfate dot 3H2O plus 2 water is Kp is given. Which of the following statement is true? So once this equilibrium is established, you can see the two substances are pure solid. So I can write active mass of water square will be equal to Kp. So partial pressure of water at equilibrium will be root over Kp, which is 2 into 10 to the power minus 2 atmosphere. So once it is true, then the expression of delta G naught is equal to minus RT ln of K equilibrium minus RT ln of Kp, and Kp is given to you partial pressure of water square. So expression 1 is incorrect. Second part is given at vapor pressure of water 15.2 torr, relative humidity of copper sulfate dot 5H2 is 100%. So relative humidity means what maximum amount of water that can be absorbed by the water is 15.2 torr, and what is the actual presence of water at this point, so that we can calculate. Since partial pressure of water is calculated as 2 into 10 to the power minus 2 atmosphere, if I'll calculate it into torr, we just multiply by 760. This will be the torr. So this you can see again 15.2 torr will come. How to be 15.2 torr. And percentage relative humidity is basically partial pressure of water upon vapor pressure of water into 100 at a given temperature. So both the values are same, 15.2 and 15.2. So relative humidity will be 100%. So option B is correct. That given in the presence of aqueous tension of 20 torr, copper sulfate 5H2O cannot lose moisture. So you can see if aqueous tension means vapor pressure of water is given. So if vapor pressure of water is 24 torr, that means humidity is less than 100%. So copper sulfate dot 5H2O cannot lose moisture. So if aqueous tension is 24 torr means moisture content is already given to you 24 torr. And in this equilibrium, what is the requirement? 15.2 torr. So this equilibrium cannot be shifted forward. It will go in the backward direction. Okay. So water partial pressure 24 torr. Equilibrium condition it is 15 point torr. Equilibrium will shift in the backward direction. So this is also correct. Next part is given the presence of dry atmosphere in the open container. Copper sulfate dot 5H2 will completely convert into copper sulfate dot 3H2. So that is true. In presence of dry atmosphere means moisture is not there. So this water will completely lost in the environment. Water will keep on, environment will keep on absorbing the moisture. So this equilibrium will slowly shift in the forward direction. And after a certain time, this copper sulfate dot 5H2 will be completely converted into copper sulfate dot 3H2. So this is also correct. If dry atmosphere is there, dry environment means partial pressure of water is almost zero. So equilibrium will shift in forward. Equilibrium will shift in forward direction. So its answer is now BCD. I hope everyone is clear now. So answer is BCD. Clear? This is the another question. Where again you have to see the concept of change of pressure, volume, and other in the effect of equilibrium. So it's given 1 mole each of H2, I2 are introduced in 1 liter evaporated flask at 523 Kelvin, and equilibrium. This is established. The concentration of HI at equilibrium is asked. So be very careful. I hope till now all of you will be understood this thing that whenever equilibrium thing is asked, there are two different questions. One, how equilibrium has affected. That is one way which we most of us know. But whenever it is in concentration of any reactant and product, be careful. you have to deal with moles and volume together. So first it's given 1 mole of H2 and I2 is introduced in 1 liter flask. So H2 and I2 will form an equilibrium as to give you 2HI. This is the equilibrium condition. And in this condition, both the reactants are given 1 mole each in the starting. And volume of the container is given to you 1 liter. And equilibrium is established. And once the equilibrium is established, the concentration of HI at equilibrium. So once equilibrium is established, so it is 1 minus x, 1 minus x, it is 2x. And this equilibrium is established. So at this time, the concentration of HI is actually 2x upon 1 liter. So what's given? Change on changing pressure. So if you'll change the pressure, certainly volume of the container will be affected. If volume of the container is affected, and we all know that it is delta and zero. So change of pressure will not affect equilibrium. Notice it carefully. I'm doing it the second time, so now I think it is very much clear with almost all of you. Still, if it is a confusion, be very careful because this is the question which can trouble you in JEE advanced paper. So since it is delta and zero, change in pressure will not affect the equilibrium. Equilibrium is not affected. That means the moles of HI, I2 and H2 are fixed at equilibrium. Since you have changed the pressure, so certainly volume has changed. Change of pressure means change of volume because moles are not affected. And if change of volume is there, then the new concentration of HI will be 2x upon V. And since volume has changed, that concentration of HI will also change. I hope all of you understood. Change of concentration, change of pressure will affect the change of change of volume, or better to say volume. So concentration change of HI will takes place. It's the answer. Equilibrium is not affected. Delta and zero case is there, but certainly equilibrium concentration of HI will change. Next, given change of changing temperature. If you change the temperature, then most certainly equilibrium constant will be affected. If equilibrium constant is affected, certainly concentration will change. In that case, any one of you can answer B is correct. Next, even change on changing volume of the vessel. Same logic. If you change the volume of the vessel, equilibrium is again not affected because it is the case of delta and zero. But since volume has changed, then the concentration will also change. So this is also answer. It given if is same even only 2 moles of HI was introduced in the vessel in the beginning. So instead of taking 1 mole of H2 and 1 mole of I2, you will take 2 moles of HI in the starting. Equilibrium will be established. So moles of HI, H2 and I2 will reach to the same value at which equilibrium has attained. Initially, whatever moles of HI you will take. But once the equilibrium has attained, in the second case, moles will be similar to the first case because again, if equilibrium is established, H2I2 gives 2HI. Initially, you have taken 2 moles of it. Now equilibrium is established, so 2 minus Y, or better to say 2 minus 2Y. Now it is Y and Y. So I can easily say that once equilibrium is established, so 1 minus X will be equal to Y. Okay. And in the same way, 2 minus 2X will be equal to 2 minus 2Y will be equal to 2X. So X will be equal X plus Y equal to 1. That will be a value which is constant now. So any one of you can say that since equilibrium is re-established with the same number of moles and volume of the container is fixed. So again, so if same, yeah, it is same even if, so the concentration of HI is not affected, same. So this is also correct option. And the last case given is even same when the platinum gauge is introduced in the catalyze the reaction. So you know catalyst affects the kinetics of the chemical reaction, but not the thermodynamics. I hope every one of you are aware of that system. So if you add catalyst, so catalyst do what? Catalyst affects kinetics. Affects kinetics means what are the parameters can be affected? Rate of reaction, activation energy. It affects the kinetics means it can affect rate of reaction, activation energy or rate constant. These are the three parameters which will be affected, and catalyst will not affect thermodynamics. Catalyst will not affect the thermodynamics of the reaction. or thermodynamic parameters of the reaction. More precisely, if you want to write, I'm writing a little shorter manner. So it will not affect the thermodynamics parameters, means it will not affect position of equilibrium. I'm covering up the theory part here itself so that we should not like, put some extra time for that. So position of equilibrium. So position of equilibrium is unaffected. Equilibrium constant is unaffected. The delta H naught is also not affected. Enthalpy, you can say. So thermodynamic parameters are not affected by the catalyst, but kinetics parameters are affected by the catalyst. So certainly, even if you use platinum gauze as a catalyst, reaction concentration of HI won't be affected. So answer will be A, B, C, D, E. All five statements are correct. So here we can mention the answer as A, B, C, D, E. All the statements are correct. And in MCQ type of questions, such type of questions are very tricky. Many options are direct, but it is a challenging question with respect to option A and C, where we have to monitor the question very carefully. Okay. Then we move to the another question, this one. Again, just a simple application of Chatellier's principle. Since I have used two, three questions in which concentration have affected, so sometimes these type of questions affects your actual concept of Chatellier's principle. So just to make them again firm, I have taken a routine question by which you all will be more than happy to feel like that Chatellier's principle carefully, properly. My intention was not to affect your Chatter's principle thing with the previous questions but in most of the questions I've done the same thing. So just to make it firm again or just to make it very clear again, I'm taking a very routine type of question. So now it's given for the reaction N2 plus 3H2 gives 2NH3 plus heat. So this is definitely an exothermic reaction. More yield of ammonia can be obtained by. So you have to increase the yield of ammonia. These can be independent questions also. I've taken in the matching column kind of question. So like I'm going to deal four questions, a single question itself. So if I have to option A, I have to mark. So yield of ammonia I have to increase. It means if I write the factors first, so yield of ammonia will be increased if I'll increase the pressure, if I'll decrease the temperature, and concentration and all will be definitely there. So first option P is not correct because given decrease of pressure incorrect, increase of temperature is incorrect. Addition of inert gas at constant pressure. So inert gas at constant pressure, it will shift in delta and positive direction. So this is also incorrect. Decreasing volume of the reaction is simply increase of pressure. So that is the correct option. So for option A, our S will be missed. And by adding of more hydrogen in the reaction vessel, so if we increase the reactant concentration, it will shift in the forward direction. So option A is S and T. Now we deal option B. So for option B, it's given now heat plus H2 plus I2 gives 2HI. So heat is given on left hand side. So it's an endothermic reaction. Delta H not positive. So it's a case of delta H not positive. So in this case, yield of HI. So yield of HI, if you have to tackle, more yield of HI can be obtained. So in this case, like delta and zero is there, so pressure will not affect, volume will not affect. Endothermic reaction is there, so increase of temperature will shift in the forward direction. And if you add hydrogen, it will certainly shift in the forward direction. So and addition of inert gas at constant pressure will also not affect because delta and zero case is there. So its answer will be Q and T. Clear? Now for option C, PCl3 gives PCl3 plus Cl2, more yield of PCl3 is obtained. So here you'll see that heat is not given. So since it is a thermal decomposition, so by observation also you can predict delta H naught is positive. Even for the first reaction, if it is not given endothermic, exothermic, you should be clear because it can be covered up from P-block thing. Hydrates of nitrogen families in our course. And there we know that formation of ammonia is exothermic while all other hydrates are formed by the endothermic reactions. So like that part can be incorporated in the question. But as I said, these kind of combinations we'll tackle towards the later half of our lectures. like when we'll complete around 10-15 lectures, then we'll do mixing of the topics. So delta is not as positive in this third case. How do I know? Because heating of PCl5 will lead to PCl3 and Cl2. So if I have to increase the yield of PCl3, so I have to shift again in the forward direction. And for this forward reaction, since it is delta N positive, so here decrease of pressure and increase of temperature is required. So if decrease of pressure is there, so option P is correct. Q is also correct. Inert gas is added, so delta N positive, forward shift is there, that is also correct answer. And S and T will not be important, because if you add inert gas in the reaction class, so hydrogen can be considered as inert gas in this case. And once reaction class is having constant volume, so addition of inert gas will not have any impact. So that will not affect the yield of ammonia. So be careful here, hydrogen will act as an inert gas. Don't get confused, because inert gas doesn't mean hydrogen, inert gas doesn't mean helium, neon, argon, krypton, xenon, radon. In equilibrium, inert gas means a gas which will not react with any of the reactant or product. So for this case, like our options will be P, Q, and R. I wish it is clear. And the last part is given H2 plus Cl2 gives 2HCl. So again, it is a delta and zero case. And in this case, since it is delta and zero, so and it is an exothermic reaction. You can see heat is given on right hand side. So increase of temperature will shift in the backward direction. Decrease of pressure will not have any effect. Inert gas will not have any effect. Decrease of volume will not have any effect. Hydrogen will increase the forward shift. So for option D, it is only T. Option D is only T. This is the answer. Just basic application of Lee-Chatelier principle. Routine question, all of you would easily solve. Now, I'm going to deal with heterogeneous equilibrium, or better to say, those heterogeneous equilibrium where all reactants and products are not in the gaseous state, or better to say phase equilibrium, more precisely if I'll say. So I've taken just one question, although it's factual question, every one of you know about it.
Sir,
Just to recall the concept, I'm taking this question. So it's given for the
sir,
equilibrium
I had a
height
doubt in
water.
the previous question.
That we'll discuss at the end of the lecture. Just give me a minute. I'm just winding it up. At the end, you'll definitely ask. So it's given for the equilibrium water solid is given water liquid. Which of the following statement is true? So you can see it is the case of phase equilibrium where ice and water equilibrium is there. So definitely Lee-Chatelier principle cannot be applied over here. So it's given pressure change do not affect the equilibrium. So in such cases, whenever heterogeneous physical equilibrium is there, or we can say phase equilibrium. So here two concepts are there. If you increase the pressure, it will shift in the more denser side. So like this is the trick which you can remember or you can recall. So in heterogeneous physical equilibrium, increase of pressure, equilibrium will shift in the direction of physical state of higher density. Many of you will be aware of that. Routine theory part is there. Just to recall, you have taken this question. So in this case, water will be formed at high pressure and high temperature. If any one of you feels like आप you forget many time, तो उसको सिंपल रूल की तरह दिमाग में फिट कर लो. नेचर हमेशा सही रूल फॉलो करता है. तो पानी मिलता है हमें ओशन में जहाँ प्रेशर भी हाई होता है, टेम्परेचर भी हाई होता है. और आइस मिलती है माउंटेन्स पे जहाँ प्रेशर भी कम होता है, टेम्परेचर भी कम होता है. सो लो प्रेशर लो टेम्परेचर आइस, हाई प्रेशर हाई टेम्परेचर वाटर. Similar type of question can be asked for graphite and diamond case also. So remember there also, increasing temperature shifts in the direction of endothermic reaction, and increasing pressure shifts in the direction of higher density. Shifts in the direction of higher density. Clear? Now this is the last question where you can say uh, coordination compound things can also be incorporated in the similar question. Or better to say, little kinetics part can be incorporated in the question. So one more question of that type. Otherwise, these things will more tackle at the time of kinetics. So it's given the approach of the following equilibrium was observed kinetically from both the directions. At 25 degrees Celsius, it was found that rate of change of concentration of PtCl42 minus is given in an expression. The value of Kc for the complexation of the fourth Cl minus by Pt2 plus S. So 4Cl minus means the equation is given, and you have to do Pt2 plus and then 4Cl minus you have to add. In that case, you have to report the Kc. Clear? So for this question, first of all, you have to understand the expression. Since rate of the reaction is given to you, so you can see in this expression, let me first write, it is dPtCl4 2 minus upon dt, and it's given minus sign, is equal to 3.9 into 10 to the power minus 5 PtCl4 2 minus. So this is for the forward reaction because PtCl4 minus is reactant for the forward reaction. So this can be written as rate constant of forward reaction Kf minus 2.1 into 10 to the power minus 3 into PtH2O Cl3 minus into Cl minus. So second half is backward reaction. So this can be referred as Kb. This can be referred as Kb. And you all know that equilibrium constant can be written as Kf upon Kb, rate constant of forward reaction by rate constant of backward reaction. So forward reaction rate constant is 3.9 into 10 power minus 5 upon 2.1 into 10 to the power minus 3. This is the result. And in the question, it is given that you have to write Kc for the complexation of the 4Cl minus by Pt2 plus. Means if we have taken Pt plus and already 3Cl has introduced to that system. So PtH2O Cl3 minus is given, let us say. And in this case, like I have added the fourth Cl minus, and then I have achieved this reaction PtCl4 2 minus. That's the game of language there. It was very easy question. So for this reaction, if you have to write the equilibrium constant, so it will be 1 upon equilibrium constant of the previous expression. Because reaction I have reversed. So it will be equal to, if I write it as, let's say, Kc, so it will be equal to 1 upon, or let's say I'll write Kc for this, because Kc is asked in the question. So let's say I'll write Kc is this. So this will be 1 upon K equilibrium. So Kc will be equal to 2.1 into 10 power minus 3 divided by 3.9 into 10 to the power minus 5, which you can write 210 upon 3.9 approximately, or you can say approximately some 53 point something. Just check, it is 53.8 approx, what answer I have. Just cross check. This must be your answer. Okay, so these are a few concepts which we are about to discuss about the equilibrium. I have tried to cover up almost all important concepts of chemical equilibrium. Still, if you have some doubts, you can definitely ask. And some part of equilibrium also we'll cover up here as a theory part, so that in the next lecture we don't affect much about the like theory part. So we can directly start problem case in the next equilibrium lecture. Okay.